In our Data Masterclass podcast, data leaders share their unique stories. In this episode, we talk to Ugo Ciracì, who is the business unit lead and engineering leader at Agile Lab. Our conversation revolved around the topic implementing data mesh at a large utility company. Let us welcome your host, Alex Borek.
Hello, data leaders. I have the big pleasure to welcome Ugo Ciracì to our show. I hope I pronounce your name well. You can correct me in a second.
Ciraci.
Ciraci, perfect. And Ugo is an engineering leader and also a business unit leader at Agile Lab. He has done over the past few years a very interesting implementation of the data mesh in a large, more traditional corporate. And we will deep dive on that. And he has a lot of things to tell us about data platform as a product, data mesh in practice, and how to basically implement such things. Welcome to the show.
Yeah, welcome. Thank you, Alex, for the invitation. I'm very happy to stay here with you and to discuss about data mesh.
Very good. So tell us about Agile Lab. So what is you sit in Italy? It's an Italian company.
Yeah.
What can you tell us about Agile Lab?
Agile Lab is let's say, a collective of professionals in the data engineering world. We like to build our skills around data engineering in a wide sense. We provide services, consulting services at a strategic level, but also implementation of big data platform and big data initiative in general. But we also build products around data engineering practices. We have WheatBoost, that is very nice platform that empower any company that wants to introduce in a scalable way data engineering practices and make the business works around their data, really. We are 150 people now. We work all in data engineering in any sense, from platform engineering to use cases. Specifically, I work as a business unit leader, as you were mentioning before, and this means that I care about a portfolio of more or less 10 projects in the utility field. One of these data mesh initiative for one traditional corporate, as you were saying before, that is a very, very big client.
Very good. And so Agile Lab really focuses on data engineering, both data platforms and use cases. And it's very interesting because, I mean, you have a really strong engineering culture, data engineering culture. I think that's really one of your strengths. I could really feel with every interaction I had with you guys.
Yeah, actually, we are in a path where we are capitalizing our long story in data engineering. We have founded a movement that is elite data engineering, meaning that there are many ways to do things right, but there is one that is better than others, and we want to achieve that goal for our customers. This is the point. The sense of elite data engineering means data engineering is a bunch of practices that a long time they didn't follow the same pace as software engineering. Okay, the pace of data engineering comes from different experiences, often, a switching mindset in a no-sense way, like from software development to scripting, or many bad practices that have been layered over time that actually they don't scale. But what we want to bring with the elite data engineering is a bunch of scalable practices that you can also implement in very complex scenarios, that the one we target actually at a company level. So our customers are all first-tier customers. And elite data engineering, yes, it's a way for us to crunch the best from the data engineering world, from strategy to implementation. And this is what we actually bring to our product.
And it's interesting because in a way it is, and it's not only Agile Lab, but I think also many companies, a counter movement to something we have seen, I would say, in the 2010 to 2000, maybe 16, 17 period, where data science was on the forefront with scripting, with a lot of R, Python that is scripted but not really used as a programming language, where software engineers help data scientists to bring it into production-ready code. But those being second-class citizens, you could say, in the data world. And now it feels like it's almost turned around. Now everyone wants data engineers. Data engineering is now much more recognized as the true value-driving field in data. And where do you see, and you also mentioned, like we are also behind software engineering. Where do you see the gaps still today, and what are the things you're trying to fill here?
It's more a cultural gap, I believe, that then reflects on all the way along with the practices. A software engineer. There are many books about software engineering, and sometimes you're going to see like that there is the artisan mindset behind a software engineer that is crafting a piece of software. But this is the creative part. This is what makes an engineer, right? So it's the creative part. But then you have to build some solid practices to reach the goal that is working at the industry level. This means that you have to scale, as in the history of the software lifecycle management, we passed from handcrafted software, handmade, let's say, on a single machine that you were going to package things and deliver them manually, and then we have stepped out to DevOps, okay? This is a big change in mindset, but also in tools that we use every day to make a sustainable the life cycle at the pace of the market for softwares. This is the same for data. We are not in the point that we can say there is a major situation worldwide for what concerns data practices and data engineering practices. So it's in a phase of discovery, even if there is a long story behind. Even when we talk about data mesh, and Zhamak was the first that said in her book, this is not a new story. This is a story of experiences, but those experiences, they are not so popular, okay? And the point we are now is that there's the need for data engineering to scale data practices, and most of the companies strive to do this because they don't know how to do that kind of job. And the reason why it's so difficult is because you have to take into account many things. It's like when you build software, you say, okay, you have to do security by design, evolutionary architecture, and many other aspects of the software development. They are just a piece of what you need to deliver data. And you should put data engineering practices on top of software engineering practices as the continuation of the story, okay, to build data practices and data engineering practices at scale. What happened is that for one reason or for another, I don't know actually, data practices, they took another way, and we are trying to reconcile this way in an effective manner with software engineering, making this work at scale, meaning that you can build your platform in a good way, using good practices, thinking holistically, but moving in agility.
When you look at, you're working closely with different clients, on a daily basis for the last years. Tell us maybe an example, a story where you could see some of the problems we have today with this state of practice, and maybe things that can help to get going.
Yeah, I can mention a few. I would like to start for being opportunistic with technology acquisition. There is a moment for any big company that you need a tool to do something. In this case, let's say to do data engineering at some scale, and maybe that you want to solve a business issue that is building some analytics in your company. At that point, you're going to choose a tool, and we're going to do a big tool selection around with big vendors, very good vendors actually, and then you're going to target the one that for you is closer to your business goal. This is a common scenario, and this is, I can understand the path, but one of the concerns that I see in this direction is that you're actually looking at the tool to solve a business goal and not, for instance, to practices that empower a company moving beyond the tool. If you build your company around practices, the practices will survive any tool because practices make sense anyway. Having a good practice will make you drive the choice about the tool in a better way than the tool can do for the business goal solely. So what we try to introduce as a concept is that practices go over technologies, and then you can actually build processes that are empowered by practices. I want to mention as a practice data quality, data observability, data lineage, for instance, at scale. How can you introduce auditability of data through data lineage, for instance, and other feature of the platform? In general, platform engineering can crunch many practices and survive to technologies if this is done in a very good way. So, the landscape now is that many companies are driven by technologies more than practices. And we would like to switch this mindset to let big companies survive technology changes and disruptive changes like data warehouse was where when there was no data analytics in that sense. Big data has been disruptive for data warehouses, targeting different challenges. And then we have a very fast pace of new technologies that are onboarding the landscape of the possibilities a company can actually acquire as a tool. But this is not enough. It's not a tool problem. Is a practice approach problem.
Yeah, and I fully understand that. I think it's, and I see that as a common thing, that you try to solve your problems by getting a new tool rather than making the organization change, which is much harder. Now, how do you approach such an organizational transformation in data engineering? You have the people that you have in a company, so maybe you either start hiring. What I saw working is either you start hiring people or you start investing in education, or you do both. What do you see?
I repeat what I was mentioning before. A company must have holistic vision and then must work in agility. It may happen that, for instance, you have a good batch of people with a nice data culture in your company, and you may want to delay, I don't know, education, for instance, because the inception is very good, and you want to base your path on different things. You may have a problem with skills, and then at that point you may want to buy skills from some other consulting services, and then but you have a clear goal in mind, and you ask for help in the execution of the strategy. There are many approaches. I believe that in the reality, it depends very strictly from the company, the big of the company, the size of the company, the target that you want to achieve in the long term and in the short term. I will say that one of the fundamental points is the commitment of the top management. This is very, very important for me. I see a big difference when there is a clear commitment from the top management of a big corporate, from the case where a bunch of people bottom up who wants to make a merge, a new practice, a new need to meet actually business goal in a clever way. But if there is not understanding commitment from the top management, it is difficult to steer an entire company of a certain size toward the right way to go. And this comes also with culture. We know that culture is moved by leaders. Mm-hmm. Top managers must work as leaders for a data initiative, and they must lead the concept, the spirit, and people in the right way. When this happens, then you have a hope to move things forward. Otherwise, it's going to be very difficult. You must find a way to buy in top managers first.
And you had one of these big sort of data journeys behind you. As explained, you were really involved in the last years in a concrete case where you implemented the data mesh for a large corporation. What was the context? Why did you decide to implement data mesh there?
Well, this context is a context of a very big company. It's like a multi-billion hundreds of billions of revenue, of a company that works worldwide in the utility industry. They are very structured, very complex organization, literally thousands and thousands of data sources spread across the company among the most suite of tools that you can imagine. Okay, this is very common for this kind of company sites. What made the difference in this case, as I was saying, it was a great commitment by the top management, for instance, and a clear vision of how to go to a domain-driven fashion. Actually, so to explain a little better the context, you can imagine one of the business line having some big issues with data and they wanted to extract more value from data. They have a big amount of data. It's all petabyte scale use cases. Mm-hmm. And in this case, extracting values, if you don't have discoverability of data sources, nice integration or interoperability to get in touch very soon in an easy way, is very difficult. But this is not only in the case of analytics scenario, data analytics scenario. This is also for operational systems, okay? So they started from the point they wanted to solve the operational issue of data integration, so making the subsystems work together in a way that is harmonic. And starting from this need, they understood very quickly that actually data analytics was the first step to do after operational systems. And the inception was very easy. Okay, we need to do a batch. Batch for what? And this from this really specific scenario based on use cases, but in a big picture, the big picture that was orienting through domains the organization of a business line of this corporate, we started analyzing which were the real needs of the company as Agile Lab, as a consulting company, and we realized that there was the right limo to build a data mesh in that context. There was the maturity in mindset to understand that the domain driven ownership of data was already there. Okay, and that was the nice way to incept the data mesh concept. This doesn't go for free, of course. There are many technical issues, architectural issues that actually we have faced and solved along the way. But the inception is a very complex situation with a nice mindset and nice shared values. It may seem like a little romantic, okay, we have some values to share, but this is the foundation for this kind of initiative that works at that scale.
What were the first steps that you took on that journey? Was it more with regards to the, let's say, platform features to simply create pipelines in such an environment for those data producers? Or was it something else? Did you approach it more conceptually? How did you approach it?
Yeah, okay. So let's consider that we were starting from an operational layer.
Right.
In the operational layer, you can see these as a population of microservices, regardless of how they were implemented. Our major concern at that point was how to extract data from those microservices respecting some rules of the operational systems. The rules are you cannot go through databases directly. You must pass through microservice APIs. Okay.
Right.
So we saw in the problem an opportunity. The opportunity was the way to go for interoperability. If you have a population of microservices, every microservice respects some standards and compliance of the operational systems.
Right.
Let's make this the way for introducing an interface that is a standard for everyone to extract data for data analytics. It's not actually so tremendous to extract data through HTTP services because all cloud provider works over HTTP. So it's not that, there's nothing actually to complain with. But it was the occasion to build an interface that is very good to extract data in a parallel way, okay? So art of light, fashion, just to mention you something that may work in a similar way. And this was the one first step to enable data analytics for all the operational systems at once, because they were all providing data through a common interface. Every microservice was in charge to implement the extraction of data in a parallel way, moving. So, if you are working in a classic data platforms, maybe that you want to extract data and move this responsibility to the batch process. Then we move this to the real ownership of the data was the operational system, and they were responsible to extract data. They know the data they have,
Right.
whether this is a relational database that they are extracting data from, or a document database or graph database. Okay, they have all the flavors, and these make the job very, very well, because all the rest of the platform can rely on a standard interface to consume data rather than copying data.
Which means that the data producing engineering team had to translate what they have, or transform what they have in the technology they have into the format that you needed, expected as a standard. Is that right? Did you have like a standard interface they need to connect to, or standard, let's say?
Actually, in terms of data mesh, just to connect some dots, so the opportunity for a output port interface, okay, with standard characteristics, standard features that we may share across all the data producers. Mm-hmm. They should work with the same skill sets, with the same kind of mindset. They are the people that know the data they actually should care about. And moving this responsibility this way, actually, of course, preparing some scaffolding and templating in the platform to help them move the right direction in compliance with the platform. Okay, this is implied, but actually nice to mention. They were all in condition to build their own output port in autonomy. Okay, considering classic data engineering problem, moved to closer to the operational systems. This is also, Alex, a nice exercise to cover the famous gap between operational and analytic systems.
Ugo, let's deep dive here on that, because I think that will be very interesting for many listeners. So what do you need to provide to those teams? You mentioned an output port, I understand that, but what physically does it entail? Is that just a standard standard template, or what is it?
It's a standard interface. It doesn't imply a specific implementation. Just to give you an example, a clear example, mm-hmm. If you want to deliver some data through the Apache Flight Protocol, okay, you must implement a connector for Apache Flight Protocol. You may implement it in Python, in Java, in whatever language you want, but you are just establishing the interface. Okay, right. Interface means the protocol, so the sequence diagram between the two actors in the system. Okay, if you want, the format of the data that you are transferring, and perhaps other needs, like which is the method so that you are using to dump the schema in and make sure that you have a mechanism for schema evolution, for instance. Okay.
And that meta information is part of that output port, or is that a different place where
all those concerns, so protocol, data formats, metadata definition for the output port, those are the definition of the output port itself.
Right.
Then the implementation is delegated to a template that is given to the final developers. They must actually implement the logic to extract data and not the interface. The interface is already built in the template. And so they can abstract from the complexity of the protocol and focus on the actual extraction logic. and then the rest is actually integrated in the platform.
So basically, you chose that output, that logical output port that was defined. You took that as a template to then drive the implementation of the actual interface. Is that right? And so this way you have a standardization because everyone was following the same output port protocol, you could say, and you could basically put that into a template.
This works. This is exactly as the rest of the world actually works for standards. If you think about it, if you say that you want to, for instance, provide events through a Kafka protocol, but
Right.
your source is actually not a Kafka topic, okay?
Yeah.
You may implement the Kafka protocol to deliver, to make consumers consume events, even if behind you don't have actually an event store. So
it's almost like a decoration, like it's an abstraction layer that standardizes it.
Yeah.
But everyone needs to then connect physically. So you can define the template, the output port, but then physically it needs still to be connected. Like let's say, I worked in environments where we had to connect an SAP to a Kafka environment. And pretend that SAP is just an event sender, basically. But that requires actual implementation work. Is that implementation work semi-automatic because you already have a lot of standardization in the platform? Or is that something that, and who does it? Is it the local data producing team responsible for the microservice? Or is that the central data engineering team who implements that? At least in this, I'm talking about your case study. Of course, everyone can do it differently.
There is a segregation of accountabilities about what should do what, who should do what, and so the platform must provide standards and compliance with standards. Okay. Also, all the scaffolding and the templating that enable people to don't focus on platform-specific concerns, but once that all the standards are enforced by compliance or computational policies somehow, and your scaffolding and templating to operate on your use case, you must only at most provide the adaptation. For instance, you were mentioning how to implement. Let's make an example. Let's consider that you have a relational database, okay, where you want to implement a data extraction for batch processing or data virtualization scenario. Maybe the data virtualization means that you want to provide facilities for a business analyst to build their KPIs or dashboards. Okay, we are not working at the data virtualization layer or the batch processing layer. They are tools outside the scope of the interface, but they connect to the interface. And they connect to the interface at the platform level. So all the batch processes and all the data virtualization systems that we provide, they natively connect to that interface through connector that have been implemented by the platform team. At that point, who is providing data to a data consumer that may want to build a batch process? The data producer should implement the use case of extraction, like in my relational database, how can I extract 10 partitions from the database? At that point, it's very clear that all the sizing and all the ability to extract partition requires a knowledge that is of the data producer team, because the relational database is something that they own. The data partitioning of the relational database that may affect performances, it's something that they know. And the sizing of the microservices to serve partition in parallel is in charge of them because they are building the microservice. So all the necessary competencies that are required to extract data at scale are already in that team.
What is the role of the data platform team here? How much easier can you make life for these data producing teams? What are the main things to make life easier?
Well, it's in this case, for what concerns output ports, the keywords I would say is interoperability first. That is, whenever you build a microservice with a standard interface, all consumers have the ability to just identify through an address, a unique address, that interface, and they can consume without anything else. So there is a zero cost of integration. This is very powerful because you are just saying that if you have a way to find that data set through an output port, then you can consume it and that's it.
Immediately, basically.
Of course, yes, immediately. Of course, you need some way to discover the data set, and then you need a catalog that lets you enable discoverability. This is something that we actually do. Discoverability is enabled by a declarative approach to how we fill metadata for each use case. So if you are building microservices, a microservice representative of a data entity in terms of domain-driven design, okay? So if you want to enable data analytics and batch processing, you must implement the output ports. Then you must declare the output port in the metadata of the microservice.
So you have to write down what this data actually contains, basically.
Yeah.
The structure, what you can, basically the expectations also towards the data. Is that right?
Exactly. And this is actually part of what concerns the data contract world, When you say that you have a data contract, you have expectation against the data that you are providing, but you have a bunch of other metadata that you want to provide to declare what the data set is actually exposing.
Right.
And from the address, the unique address of the output port to all the schemas and metadata about the schema. So what means every field, what does every field means, what is the glossary that you must use for that schema, which are the interconnection enabled, the data governance policies that you want to apply. Everything is declarative and is brought through the microservice deployment that actually embed the concept of a data entity of domain-driven design. Delivering this value all together, okay, like an architectural quantum, if you want to talk also in terms of evolutionary architectures. The architectural quantum is pretty good in that because if you deploy it only once, then you are going to enable many features. Interoperability because you can actually apply enforcement through computational governance that are based on the metadata. If you declare something that is not in there, then you can stop the deployment. You enable discoverability because you can use the declaration of that entity to feed a catalog.
Yes.
You can enable incentivation because once you put this in the catalog, everyone can comment, theoretically can comment or complain about the compliance in terms of, for instance, data model with what the business actually needs.
Yeah.
And so it's a virtuous cycle because this is the inception for the platform to enable a lot of other features.
Now, let's dive into the data catalog for a minute. So the data catalog at the end in the data mesh is where you display these metadata that are coming with the output port. So it's not where the data is produced for this data catalog, but it's more where you visualize it for everyone. Is that right? So you basically put all these, you could say, information that comes with the data product and put it into automatically into a central place.
Yeah, actually, this is a nice difference between what we at Agile Lab, what we look when we talk about data mesh or data mesh supervising rather than just a data catalog. A data catalog, you may have the same data source in a classic way. You can have several data sets coming from data source, Oracle database, Postgre, MongoDB, Neo4j, whatever. And then you have a process that transform those data from the source to another table and so on. For data mesh to work very well, this is not an experience of this customer because we have built a data catalog that actually is an extension of their service catalog. It was a microservice platform that we have extended to data analytics. But there is something that you can do actually that we build actually in our product. That is a way to look at the data as a product. And then you may have for the same data different output ports. They are just view of the same data. Maybe you can have a data that is very good for massive consumption and data that is very good for business analytics, for business analytics like dashboarding. And then you have the same data that you are delivering through events, because every time that you have a mutation in your database, you deliver this event as an event that is representative not of the mutation of the database, but the change of the data interface for the data product. This means you don't have details of your original systems.
Yep.
You are focusing the event that you are delivering through a business-driven mindset.
You're abstracting, which is very important. You're decoupling. Now, question here is on the when you have the data products and you talked about contracts. How do you know that somebody is consuming you? Is that also by design built into that data? In your case example, was that built into the data platform that you could register as a user, as a consumer?
In our case, there is a strong decoupling between consumers and the producer of data. This is a kind of attribute-based access control. Okay, meaning that for instance, thinking about data analytics, of course, if you have a data set and data set is represented by a schema, then you may annotate every field with a field type. Okay, this is a name, this is a full name, this is a last name, this is a zip code or something, and those are categories of fields.
Right.
Then we have a class of data. Class of data are a set of set of field categories. Okay, meaning that, for instance, we have PII class of data, and PII is just listing as categories whatever is a personal identifiers, first name, last name, and this is for data privacy reasons. Maybe that you have a class for commercials, and then you have other field categories that classify real fields of a schema, and then you have a layer where you bind final users. Final users can be an entire organization, a single person, or an application. Okay, you classify those final users through those data classes. Who is classifying the data user are the domain owners with respect to their needs and their knowledge about data governance, compliance policies. This means that the process more or less looks like this. You are a data consumer, you subscribe to a data set, you ask for, you are classified at the origin of your data classification, of your subscription through a data class. Then through subscription, you send a request to the domain owner. The domain owner receives the request, approve it or not. Approving it, you are approving all the data classes that you are being subscribed to. From that point on, you are authorized to read or manipulate data for all the data classes you have been approved in the first cycle.
So it's highly automated, basically.
Yeah. This is a nice approach because you can really decouple the responsibility of the domain to classify their own data,
right,
to what the final users need.
Yeah.
The data governance implementation is something to take really care of. That is something that people can strive to implement is a good way to transfer those data governance information in the metadata architecture. Metadata is a concern by its own. So when you think about how to implement a platform, you should care about the metadata architecture.
And that is important because you want to go into more automated governance, automated federated governance. And that's why you need to infuse some of that governance-related information into the metadata. Is that right?
Yeah. I mean, the ambition should be how to make every decision be computational. In a complex, very complex world of decision, when you have to take decision from which architecture to take, which infrastructure to implement, which business rule to apply to a situation, then there are two ways: the manual way, and then you get lost in millions of documents spread across many document management systems. And then you have the other way, that is driving the decision process through computational policies. This actually is very important for data governance, but I would say that is the way to go for everything. In the end, if you think about infrastructure as coded infrastructure, those are policies that you are coding about how the infrastructure should work. They provide compliance with many aspects of a company, even perhaps with the regulation that can come from regional laws or whatever you want. The same works for data governance. Data governance must be embedded in the platform that you are providing, because in the end, it's all about what the platform is able to enable to the final users. And it must provide data governance in a way that is transparent, the complexity, but very clear the goal for the final users. This means that the domain owner or the domain developer, they are building the use cases, they should only care about their metadata and on other metadata that they don't know how to handle. They should have the right interface to write their metadata. For instance, I don't expect a business user to go to Git and write a rule on Git. They don't know what Git is, okay? But the developer, I don't see a developer going to a nice web interface to commit their code and their rules. So those are all metadata that you are driving the computational governance with. They belong to metadata architecture. They enable governance at many levels, including data. But as I was mentioning again, it's an holistic view in agility.
Yeah.
Then you must introduce your feature in the metadata architecture to enable data governance, data classification, classification of data consumers, bind them with policies. Then you may apply some policy engine in your infrastructure and your architecture that is able to compute policy and maybe throw policy as code. And you build professionals that are able to think about the policy logics in a business-driven way, not caring about the implementation. Should I implement my computational policies in Python or with a proper language that is understandable by the guy that is going to write those policies to be computational?
Ugo, could you provide a very simple, can be just made up example of such a policy? You know, like what could a policy look like in practice? Just one example.
A policy in the utility sector, okay, there are lots of regulatory rules coming from the region you work in. For instance, in South America, you don't have the so-called unbundling, while in Europe you have the unbundling, meaning that you are splitting into the market of energy between who can sell the energy and who can actually distribute the energy. Okay, this means that you may have some data products that can talk with other data products. You want to, if you don't put any policy,
right,
you want to prevent those kind of data products belonging to not only different domains, maybe different company that works in the same data mesh.
And we are not allowed to share the data directly, basically.
To connect to each other. This is a kind of policy that you can easily implement that actually is all in the business case of a region. So maybe that you need the metadata that identify the region, and then you can apply this kind of policy, okay? And then you can build lots of rules, practical rules that make you able to, establish top-down rules that you can make them work from day zero or with a period of adoption or whatever is the onboarding that you want to do for that kind of policy.
Great. Maybe the last topic and the data mesh, and then you also have beyond, rules and regulations, you have also the concern of quality and observability. Maybe very quickly, how did you approach that? Just to give us a glimpse.
Yeah. This is one of the example of practices over technologies again. We wanted to split the need for, I want to use this tool or the other to implement data quality, because it may be that you have domains that have consolidated knowledge of a specific data quality tool. I don't want to mention any, but there are many, and they are worth to mention actually. In this case, what we wanted to do is how we can provide the platform with a standard interface to expose data quality without affecting the real implementation that they have. At this point, we decided to build interfaces like control ports, able to expose in a standard way data quality, but then you can implement however you want those data quality metrics or KPIs or whatever you want. The important is that you, as a domain, you build the adapter. Actually, we did also a default implementation to say, you don't like the default implementation, then you can use your implementation.
Right.
In the end, everyone is using the default implementation because it's more comfortable. But there is the ability to split your technology-specific knowledge from what you need to expose.
Great. Ugo, thank you so much. This was a great session on data mesh and computational governance and how to provide platform as a product for data mesh, and a really exciting case study where you, I would say, done a lot of the work already.
Yeah.
A lot of people have in front of them.
We have to do a lot so far. Anyway, thank you very much, Alex, for the invitation. Very nice to talk to you to discuss about data mesh, Agile Lab, and our new challenges. Hope we will see next time.
Thank you, Ugo.
Boric Data Masterclass, where great data journeys begin.